So I'm making this video because we seem to have a lot of questions about furlers and how the system works and how it's assembled and how they go together. And I just took my old one apart, and this should give you a fairly good understanding. So first of all, this is the lower drum unit. You'll see this on your boat, and this is the bottom of the stay. Now, it isn't always a turnbuckle. Sometimes there is none, but in this case there is. And this slides up inside the furling unit, and these two ears engage in these slots right here, and a set of screws goes in there, and that holds the bottom of the drum stable while the rest of the furler rotates. From there, obviously the line loads onto the drum. You see that, but we're going to focus on the internal components here. So then this is your lowest foil, and most furling systems are very similar. So this is the lowest foil, and this extrusion here has a unique shape that corresponds with the drum. So this will slide down into there, but first it has a small bearing or short bearing that inserts into the foils so that when it spins, because it spins around the wire, it doesn't wear. The wire doesn't wear in this hole, the wire wears in these plastic sleeves. So this goes together and slides up inside here, and is held in place by another screw. That's the bottom of my forestay. It's a mechanical fitting stay lock. Yours, or often they might be a swage. So then, as you go up, here's a pre-feeder where the sail slides in on your bottommost extrusion. This is the Halyard Swivel. This engages and slides onto the bottom before assembly. Typically this would pull your sail up the mast, and the halyards would attach to this portion, and this rotates so that this rotates independently of this section, so that when the sail is furling and spinning up, your halyard can remain static and not wrap around the top of the stay. It's a really bad thing if the halyard wraps around the top of the stay. So going up, the foils are all interconnected, and most furlers are very similar with some type of joiner sleeve. So the joiner sleeve has a slot in it. Sometimes it has to be slid onto the stay beforehand, but most of them have a slot that drops on there. There is a bushing, another set of bushings typically that engage inside there. So you would engage one half, insert your sleeve, and it actually gets a half turn before you then slide it in. And that's why you see those little screws at every interconnection of your furler. This is what holds each foil section together and also creates a bearing every roughly 6 feet. So there's one set of those every 6 feet the whole way up the furler. Give you some perspective. This is all taken apart. And then you get to the very top, and there's usually a top bearing of some kind. Profurl does one like this. Every other furling system has a similar system, and it slides down inside the extrusion over the wire, of course, and also has plastic bushings of some kind. And in Profurl's case, it's held in place with a C-clip that sits in the top of the bushing right here and stops this bushing from being lost and sliding down inside the foils. And then also in Profurl's case, they have this wrap stop device which clamps onto the wire up here, which in theory, if their halyard's trying to wrap around, the stay, this should catch the halyard and prevent that from happening. It does work fairly well unless the bearings are starting to fail. And that's just the top of the stay where it attaches to your mast and has articulation so it doesn't fail. That basically the entire system. Again, joiners every 6 feet. Little set screws in each one. All the set screws are here. They're just small. They should be Loctite in place so they don't fall out. These are the fasteners these bigger ones are the ones that secure these link plates right here to the sides of the drum. And then there's another set of fasteners that secures the foils. When this foil here engages into the furler tube, there's some set screws that stop that foil from sliding up and down. They don't stop it from rotating because the shape of the extrusion does that, but they do stop it from sliding up and down. It's very important because if this were to slide all the way down and jam this bearing onto the swage fitting or your stay lock fitting, your furler would be really hard to turn, and we see that quite often actually. All right, well, this is a Profurl. Hope this helps.